Okay, so chapter 10 is a unit on gases, and I think what you'll find is there's not much new here versus what we did in Honors Chem, so you'll find it to be pretty easy. It's kind of a review of gases and stoic and some other things. A little bit of an expansion. So you know gases, unlike liquids and solids, they expand to fill their container. So if I have gases in a, let's say in a vial, and I open the lid, the gas is going to come out. It's going to fill whatever boundaries are around it. Okay. We know gases are highly compressible. I can take a balloon and I can squeeze it because the particles of air are so far apart that I can make them come closer together. And for the same reasons, they have very low densities, so not much mass per unit of area, which is why gas densities are typically expressed as grams per liter as opposed to grams per milliliter, which is more typical for solids and liquids. So when we're doing problems, make sure you recognize that the units are likely to be different. So you really can't talk about gases without talking about pressure. So as you know, pressure is the amount of force applied to an area. So it's simply force over area. And what we have is this force of the atmosphere pushing down on us. And the closer we are to the center of the Earth, the further this atmosphere, this column of atmosphere is above us, and therefore more pressure. So you're high up in a mountain, you're going to have a lot less pressure than you will down at the bottom of a valley. So pressure units are, if you think in terms of physics, it's some unit of force over some unit of area, and typical would be newtons per meter squared. Doesn't usually work that well for chem, so there's newton per meter squared has another unit that is equal to that, and that's a Pascal. Usually when we are talking about gases, we tend to use several different units, and these are all units at STP, and STP assumes 0 degrees C or 273 K. So all of these things are equal, 101.3 times 10 to the 5th pascals. The actual scientific standard, the SI units, are 101.3 kPa. 760 millimeters of mercury is also 760 torr, and 1 ATM. We tend to use mostly ATM, and what you'll find mostly on the AP exam is ATM. Alright, so let's do a little bit of conversion. A is convert 0.357 atmospheres to torr. So if I have 0.357 atmospheres, what I know is 1 atmosphere is 760 torr. And if I punch that into my calculator, I get 0.357 times 760. Should have 3 sig figs in my answer, and I get 271 torr. If I'm doing this part B here, it is convert 6.6 times 10 to the minus 2 torr to ATM. What I know is 760 torr is 1 ATM, and if I punch that, I'm going to get 6.6 second EE negative 2 divide by 760, and I get 8.7 times, looks like I want 2 sig figs, 8.7 times 10 to the minus 5 ATM. And lastly, I have 147.2 kPa, and what I know, and I want to convert it to torr, and what I know is 101.3 kPa is 760 torr, and if I calculate that, I get 147.2 times 760 equals divide by 101.3, and I get 4 sig figs, 1104 torr. Okay.